Alright, this is just a quick overview of Lesson 34 and Lesson 35. The actual amount of content in these two lessons is pretty low, so just kind of pay attention as we go along, and it goes pretty quick. Now, Tycho Brahe was basically an astronomist who spent a lot of time looking at stuff. I mean, he collected a lot of data and just basically a lot of raw information. History-wise, he's got a few interesting ones, of course. If you take a look here, he basically lost his nose in a duel, so he had like a copper nose put on, which is kind of interesting. The other thing that's interesting, well, I think this is interesting too, the fact that his pet moose died because it got drunk. But the history of his death is somewhat interesting as well. That apparently because he held his pee because he didn't want to go to the bathroom because it was rude, he stretched out his bladder and got an infection and died. The other interesting hypothesis on his death is that he was assassinated by his assistant, who was the next person we're going to look at, Johann Kepler. Johannes Kepler was his assistant, who basically took the data from Tycho Brahe and used it to come up with three key ideas, which is Lesson 35. The first, as mentioned here, is that all objects actually travel in an elliptical orbit. Even if those foci are really close together, these two dots, so it's very close to a circle, all orbits are elliptical. A lot of the better orbits for maintaining life would obviously be closer to circular. The second key point is this. An imaginary line, blah, 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 sweeps out equal areas in equal time. What this means is if we take a look at this example here, where we've got this pie shape and this pie shape here, on different orbits, those pie shapes are of course different. But the key point of Kepler's second law is that the area contained is the same. So I mean, if you're cutting up the pizza and dividing it up, both people there would get the same amount of pizza. This person here with kind of the short stubby piece, and this person here with the long skinny piece. The third of Kepler's law is the one that's mathematical, which is basically that all objects circling a particular object will have a constant. That constant will be the square of the period divided by the cube of the radius. So what this means is anything that, say, orbits our sun will have the same constant. If we, per se, were to have more than one moon, those moons would all have the same constant. It'd be a different value than the constant for everything going around the sun, but the constant would be the same for all objects circling the Earth. And this applies to what we would call artificial moons or satellites that we put in orbit. So that constant for the moon would be the same as the constant for those satellites. And that's it. Those are Kepler's three laws. Now there's of course some mathematics that you can use. You may want to play around with your calculator because you're going to have to do cube roots, not just like the square root. And if you don't know how to use your calculator, that could cause you some grief. Now there's some examples there, but that's it. So hope you figured something out from lessons 34 and 35. See you in lesson 36.